All right, let's return to our very first example of this whole section. How many pages do I have to go? Let's look at one of these. Whoa, this is supposed to be a circle. Pretend. All right, and remember that if we have a discontinuous integral, we may have to split it up into two continuous pieces. That'll bring us to example 6. Integral from -1 to 1. All right, it's not exactly the same, but it's very, very close. Of 1 over x to the 2/3. So this is not continuous. There is an infinite discontinuity at x equals 0. Right? It's going up like this. We're looking at this area, but we have to split it up because it's not continuous. Fundamental theorem of calculus will not work out to give us the right answer. So we have to split this up into two continuous pieces. -1 to 0 plus 0 to 1. Ooh, I just also thought of a really good explanation for those two-sided integrals. I'll probably bring it up during selected homeworks problems. Okay, so then what we have here, we can just do each one of these like we did in examples 4 and 5 in the last video. So we know the antiderivative of 1 over x to the 2/3. We can add a power. This is x to the -2/3. We add a power and divide by the power. It looks like this. That's the antiderivative. But we don't want to cheat. This is going off to infinity when x is 0. And specifically, if x goes to 0 from the right, it's positive infinity. Oh, it's positive infinity either way. But it's going off to infinity, so it's we have to use a limit. It's the limit. As a goes to 0 from the left, we have to approach from inside the interval. Integral from -1 to a of 1 over x to the 2/3 dx, plus the limit as b goes to 0 from the right, we have to approach from inside the interval. Integral from 0 to, from b to 1 of 1 over x to the 2/3 dx. Right, so what is this going to be? This is going to be, well, it's just still the limit. Let's look at the antiderivative. 3x to the 1/3 plus c from -1 to a, plus again this other limit as b goes to 0 from the right of, just like before, 3x to the 1/3, same antiderivative, but now from b to 1. Now we just use a fundamental, well, we're already using the fundamental theorem of calculus. Continue using it and evaluate the limits. That's all there is to it. I'm going to write these as cubed roots. I like looking at cubed roots. Minus 3 times the cubed root of -1. Plus the limit as b goes to 0 from the right of 3 cubed root of +1 minus 3 cubed root of b. Well, as a is going to 0 from the left, this goes to 0. As b is going from 0 to the right, this is 0. So I said you had to split this up. You can't use the fundamental theorem because it's not continuous. If you did cheat and didn't split it up, if you didn't use anything from this section, you would have stumbled upon the right answer for the wrong reasons. Sometimes you get the right answer doing the wrong things. Many times you will get the wrong answer doing the wrong things. Okay? So it is important. You won't always get the wrong answer for it, but it is important to do things correctly. And again, there are many cases where doing it without the limits and without splitting up will get you the wrong answer. Okay, so this is just going to be, this is +3. This is +3. We get the answer as 6. We should be able to check our answers using Desmos. Integral from -1 to 1 of 1 over x to the 2/3 dx. Huh. That's not 6. What's going on? 1 over x raised to the 2/3. Looks like this. So our picture was right. We're looking from -1 to 1. All right, so from here to here, the area under the curve. Fun fact, this is a height of 1. This is this box is 1 by 2. So a third of the integral, the third of the area is just right here. And then this whole area up to the top should be 6. Why didn't Desmos tell us 6? Because of the way the computer works. There's some rounding errors. Computers are not very good at dealing with infinity of any kind. All right, so our answer is actually better than the computers this time. Take that, Desmos. But yeah, this is the right answer. And that's something that will happen sometimes with computers, depending on what algorithm they use to evaluate those definite integrals. Because I can tell you what, they're not doing this algorithm. We're kind of skipping the way that computers evaluate integrals in this class. There's some of it on chapter 3. 3.6 is numerical integration. Numerical a lot of times means computers and stuff like that, but we're skipping that. Anyway, that's it for this video. Good luck. Let me know if you have questions. Bye-bye.